This section deals with quadratic functions. Now, we're accustomed to seeing quadratic functions in the form f of x is equal to ax squared plus bx plus c. Well, that's called general form, and now we're going to look at standard form. Well, the standard form of a quadratic function is f of x is equal to a times x minus h squared plus k. And this is where hk, so h and k, is the vertex of the parabola, or the turning point, and a is the compression stretch, same as we saw before in transformations of functions. Now, a couple of things. If that value is bigger than 0, if it's positive, then our parabola opens up. That makes sense to us because we know that that would be a compression stretch where the y direction would be the same as the key points. If a is less than 0, the parabola would open down. And again, that makes sense. That's something that we're used to, because if there was a negative compression stretch, we would be reflected. And for parabolas, we would go from looking like this to being reflected on the other side of the x-axis. So the blue graph represents where a is greater than 0, and the pink graph represents where a is less than 0. Lastly, when you are in standard form, you are able to find the line of symmetry for the parabola. So the parabola will be symmetric with respect to the line x equal h. So this is the line that if you draw it, the left and the right will be a mirror image of each other. So let's look at some examples. And in the first few examples, what we're going to do is we're going to determine the vertex, axis of symmetry, and range for the following functions, and we're also going to graph them. What is the vertex of this parabola? Well, remember again that the standard form for a quadratic function is f of x is equal to a times x minus h squared plus k, and that's where h and k are the vertex. So let's take a look here. Well, if you look at this h and k, doesn't that really look exactly like a horizontal shift for h and a vertical shift for k? Well, that's because those are exactly what they were for transformations of functions. So the h represents that horizontal shift that we knew from before. K represents the vertical shift. So I'm going to take a look at the first function. Again, I have f of x is equal to 2x squared. So let's find the vertex. So my h would be a horizontal shift. So is there something in here with x that I'm squaring? There isn't. So the h value would be 0. Again, if you look at this, there is no horizontal shift. And again, the h is that horizontal shift. I don't have one. I don't have an h for this particular problem. K is the same as your vertical shift. Well, is there a number I'm adding out here? No, there isn't. So my k would be 0. So the vertex for this particular parabola is 0, 0. So let's go ahead and plot that. Then it asks me for the axis of symmetry. Well, the axis of symmetry is always the equation of the line x equals something. And the something that it's going to equal is h. So what is the h value for our particular graph? Well, that is 0. So the axis of symmetry for this particular function is x equals 0. Well, in order to find the range, we should graph the picture. So let's go ahead and graph the picture. Well, if I take a look at this, I already have the vertex is 0, 0, right? That's the horizontal shift and the vertical shift that we can do, again, so easily because we know transformations of functions. Well, then we have that 2 out in front. Well, what's that 2? That 2 is our compression stretch. So that compression stretch tells us to go up 2, and then we're going to go left and right 1 to get that shape of a parabola. So up 2 units, left 1, back to the vertex, up 2 units, right 1. So this is the graph of the parabola 2x squared. Also note, I'm going to draw in the line x equals 0 because that's the axis of symmetry. So if you look at this green line, everything to the left and everything to the right is identical. So it kind of acts like the mirror for both sides of the parabola. Okay, back to the range. We need to find the range. Well, we know how to write the range from pictures. Ranges are y values. We're writing this in interval notation, so we have to go from the smallest value to the largest value. So we start down here. What's the first thing that we get to? Well, the first thing we get to is that dot. Well, where is that dot located? That dot is located at y equals 0. So the range goes from 0, and it's included because we have a closed circle, and we keep going and we keep going and we get to arrows. Well, what are those arrows? That means positive infinity, so our range is from 0 to positive infinity. Alright, let's look at the next example. we have 1/4 x squared minus 1/2. Again, let's find the vertex. Remember the vertex is hk. H is the same as your horizontal shift. K is the same as your vertical shift. So take a look here. Am I adding or subtracting a number here with x that I'm squaring? No, I'm not. So there is no horizontal shift. If there's no horizontal shift, then we know that h is equal to 0. Then do I have a k? Do I have a vertical shift? Am I adding or subtracting something to this function? I am. I'm subtracting 1/2. So the k value of our vertex is negative 1/2. So let's then find the axis of symmetry. Well, the axis of symmetry is always x equals some number. The number it equals is the x value of the vertex. Well, the x value of my vertex is 0. So the axis of symmetry for this graph is going to be x equals 0. Then we're asked for the range. Again, the range is easier to do if we are graphed. So let's graph ourselves first. And if you notice, our compression stretch is 1/4. So what I'm going to do just to make this a little easier for us is that we are going to change the scaling for our graph, and everything's going to go by 1/4. So here's negative 1/4, negative 1/2, positive 1/4, positive 1/2, positive 3/4, positive 1, and so on. So we're just labeling this particular graph by 1/4, so each one of these points is 1/4, just so that we can graph our function a little easier. Alright, first I need to plot my vertex. Again, my vertex is 0, negative 1/2, which is right here. Then I need to use my compression stretch to find those key points. So from this I need to go, since this is positive, up 1/4, and then left 1, up 1/4 back from that vertex, and then right 1. That is the graph of the given parabola. Again, if I were to draw the axis of symmetry, which is the line x equals 0, both to the left and to the right of the axis of symmetry, it would be a mirror image of myself. What's the range? Same thing. Go along for the bottom. What's the first point you get to? Well, it's that point right there. What is the y value of this point? Well, the y value is negative 1/2. It's a closed circle, so my range goes from negative 1/2. Keep going until I end. The last thing I get to are arrows, so that means that I go from negative 1/2 to infinity. All right, let's look at a third example of this. I have negative 3 x plus 1 squared minus 2. Again, I first need to find the vertex. Remember, your vertex is your horizontal shift for your h value. So do I have a horizontal shift? Is there something I'm adding or subtracting x in here? Yes, I'm adding 1. Remember, the horizontal shift is always opposite your intuition. So a plus 1 would make it negative 1 for that h value. Okay, again, a plus 1 would make it a negative 1 for the h value. Do I have a vertical shift for this function? Let's see. I have that minus 2. So my vertical shift is down 2. So minus 2 and negative 1. So the h here is negative 1 and my k value is negative 2. Remember, horizontal shifts are always going to be opposite. So if this is a plus, we would write minus. All right, what's the axis of symmetry? Again, the axis of symmetry is an equation, and it's x equals some number. Well, what is the number that I equal? The number is negative 1. So the axis of symmetry is the line x equal negative 1. Again, the range is easier to find once you've graphed. So let's figure out what the compression stretch is. Well, that compression stretch happens to be negative 3. So first, plot your vertex. Your vertex is negative 1, negative 2. And then we're going to use our compression stretch of negative 3 to find those other key points. So from this vertex, I go down 1, 2, 3 units and left 1. Again, from the vertex, I go down 1, 2, 3 units and right 1. Again, I'm going down because my compression stretch is negative. So connect the dots here. And then I'm going to go ahead and draw my axis of symmetry, the vertical line at x equal negative 1, which is right here. Notice again, I'm a mirror image of myself to the left and the right of that line. All right, let's find the range of this function. Well, range is always lowest y value to highest y value. So if I go along, the first thing I get to in this function are arrows, which means that I'm going from negative infinity. And then if I keep going, I'm going to get to the highest point being that dot. Well, what's the y value of that dot? Well, the y value of this dot is -2. So my range is from negative infinity to -2 with a bracket again because it's included. In the next video, we're going to look at how to look at quadratics that are in general form and put them in standard form.